But one thing you will notice that this is focusing a lot on the majors and the minors. And if we look back at our origin, we have the dominant and the diminished. So somehow this fractional kind of thing is like a nice idea, but it doesn't quite match our natural scale. It doesn't match our different modes that we have. But what if I told you that we could go beyond? So one thing we will notice is that if we had the circle of fifths, so at the beginning it was looking at the tones versus semitones. So a tone is a +1, sorry, a +2, because we're counting on semitones, and a semitone is a +1. And so our scale, if we just look at the tones and semitones, it's going to be tone, tone, semitone, tone, 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 semitone. So it's going to be tone, tone, semitone, tone, 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 semitone, right? And if you look at this, if we add everything, it adds up to 12, right? So that makes sense because we have 12 semitones in total and we have 7 notes, but there's not real way to split 12 semitones among 7 notes. If we look at the fractional differences, now everything is either +1.5 or +2.0, and it's gonna begin with +1.5 and alternate. So it's gonna be a, I'm gonna switch colors to +1.5, +2, +1.5, +2, +1.5, +2, and +1.5. If I add all of these, I also get 12. But this is a more even way to split them because now we have we can divide by 2. So we can take a more granular approach to all of this. But then of course, would there be a perfect way to split things? Well, what if we just had +12 over 7th? And then another +12 over 7th? And another +12 over 7th? And if we have 7 of these, we should get a 12, right? So this would in theory be the ideal way to split the 12 semitones. And so what I'm going to do, and this is what I'm going to call the diatonic fractionals. I'm gonna mute this. And so for now, let's just look at this. So this is 0, 1, 2, 3, 4, 5, 6 multiplied by 12 over 7. So this is going to give us the root, the one that is +12 over 7, the one that is +12 over 7 twice, the one that is +12 over 7 3 times, and so on and so forth. And then I'm just going to add 0 to that. Okay. What do you think will happen? We're just going to play that. And well, we get... Alright, so these are going to give us fractions, so all I'm going to do is round them. So for example, if I have 2 plus 1 over 7, that just rounds to 2. But if I have 2 plus 6 over 7, that's much closer to 3 than to 2, so that rounds to 3. Okay, and so that's going to do, at the end of it, I'm going to round it. And so that is going to give us 7 notes. So it's going to give us a scale, but the question is which scale? And if we look at it and observe it, it is none other than the Dorian scale, because it's symmetrical. It is 0. Let's just play it. That's 0, 2, 3, 5, and 7. And then it's 7, 9. But instead of getting 11, we get 10. Yeah, so just remembering that's our tone, that's our minor third and our minor seventh, that's our perfect, minor third and minor seventh, that's our perfect fourth, perfect fifth, and that's our major sixth. So if this was a minor, this would be the Aeolian scale, but it is not. It is the Dorian scale, the one that is symmetrical. But if you remember, what we could do before is start with either 0 or 0.5, and we got either the minor things or the major ones. So the question is, what happens if instead of beginning with 0, we begin with 0 plus, or let's say 0 minus 1 over 7. What do you think will happen? It's exactly the same, except that the sixth is now minor. So if we have this one is our Dorian, this one is our Aeolian, which is our minor mode. Yeah, we observe it and it's our minor mode. If you have minus 2 over 7, now the second is minor, and that gives us the Phrygian mode. And if we do 0 minus 3 over 7, we lose our perfect seventh, sorry, our perfect fifth, because we are now in Locrian mode. If we do plus 1 over 7, we get our Mixolydian. If we get 0 plus 2 over 7, that's our major mode, that's our Ionian. And if we do plus 3 over 7, that's our Lydian. And you remember that I mentioned that the Lydian and the Locrian are actually very close to each other because they just differ by one thing. Well, guess what is 0 plus 4 over 7? We're back to Locrian, but one note above. And so what we can do is we can give every rooted diatonic scale, rooted, I mean that I actually care about what the root is, not just what the notes are. And diatonic, I mean it's one of the modes. And each of the one of them, I can give them a number, which is a fraction. So for example, what would be C major? That would be, well, 0, because that's my C. I could have used a different reference point, but for now we'll use C as our reference point. So C's are 0, plus C should be major, so that should be a plus 2 over 7. On the other hand, maybe I like B minor. So that would be -1, because that's B, -1/7, because it's minor. On the other hand, maybe we want, I don't know, F Dorian. And so F Dorian, what is F? F should be like 5. What is Dorian? +0/7. And so every different diatonic scale which is rooted, I can give it a number. And same as before, we can start thinking about intervals. So for example, what is the difference between C major and C sharp minor, right? Well, to go from 0 plus 2/7 all the way to, how is it called? Well, it should be 1 because it's C sharp, but it's not minor, so it's -1/7. And so the difference is actually 4/7. Let me just double check that. So 0 plus, yeah, right. And so this is slightly bigger than 0.5, which was the difference between C major and C sharp minor in our theory, just using majors and minors and 0.5s. So that's an interesting observation. Another interesting observation is that now we can ask, well, what is the difference between, and now this difference is always going to be the same. So we're going from C major to D Dorian, if I remember correctly, and so it should be 1 plus 1/7. Sorry, 1 minus 1/7. Because we're going from, sorry, not 1, it should be 2. Because we're going from 0 plus 2/7, we're going down to, that should be 2, because we're skipping over the C sharp, and that should be +0/7. And so it's not -1/7, it should be -2/7, right? On the other hand, the thing that we were quite interested in, our third, and this interval will be the same everywhere. So for example, we're going from E, that should be one of the different minors, but it shouldn't be, this should be the like, the -1/7, right? And this should be 9, right? E, on the other hand, is going to be the one that is Phrygian. So that's going to be 4 minus 2/7. And we do notice that the difference from here to here is going to be 2 minus 2/7. F is going to be Lydian, so F is going to be 5 plus, Lydian is one of the highest, so it's +3/7. And we do notice that if we do 4 plus 2, it gives us 6. But if we do like -2 minus 2, we get -4, which is the same as going from 6 to 5 and +3/7. Yeah. And so of course now our like our third interval is going to be twice of this, so it's going to be plus, well, I can check this, so it should be +4 minus 2/3. +4 minus 4/7, which is the same as +3 plus 3/7. And this, you will notice that 3 plus 3/7 is very close to +3.5, which was our going up a third in our major world. That was our big important interval. And so now we see why the 3.5 escapes, because the one that stays is a 3 plus 3 over 7. 3.5 is a little bit too big. So if we do it long enough, the 3.5 is going to escape, whereas this one is going to stay. So yeah, and so that's just within the diatonic interval. But as you start doing like modulation between different modes, going from one chord to a completely random other chord, you can start to understand them using this kind of notation. Yeah, I think that would be the end of the video, and apologies for being a super long video once again. Bye.